In this video, we're going to look at a couple examples of finding the factors of higher level polynomials and then being able to solve for the solutions to the equation. Now, in order to do this, we are going to use synthetic division until we get our higher level polynomial down to a quadratic equation. Once you hit a quadratic equation, then you can use all of your algebra rules for solving a quadratic equation to finish out your factors. So here we're going to go ahead and we are going to start. Now, the first thing to do when setting up is we need to set up our box. Remember, the box is going to be what your potential factor goes into. And then you're going to use the coefficients of all of your numbers. We're going to go down in descending order, and you need to make sure that you hit each power down as you go. So this first one is going to be -1, and then we have 2, 3, -4, and -4. Now with that, this first term is going to just simply drop all the way down, and then you have to draw your solution bar. So this first term is going to drop down as the -1. Now we need to figure out what we're going to put in this box here. If you don't automatically know what your zeros are supposed to be, a good one to test is positive or -1. Now, since a little more than half of these values are negative, the first one I would start with is -1. Now your goal is that this end result here is a 0. If that happens, then this is one of our factors. If it doesn't happen, then we would need to test something else. So here again, you're going to do bottom number times the box goes underneath the next. So -1 times -1 is a 1. And then what we do is we do old school vertical addition. So we're going to add 2 plus 1, and that's going to give you 3. And repeat. Bottom number, so 3 times the box, which is -1, so this is -3. We're going to do our old school vertical addition again. So -3 plus, or 3 plus -3 is going to give me 0. Bottom number times the box gives me 0. We're going to do our old school addition, so -4 plus 0 is going to give me a -4. Bottom number times the box, it's going to give me 4. I'm going to do my old school addition again, and here we get a 0. Now, since we got a 0 here in this last box, what this means is that -1 is a factor. In other words, it worked because I got 0 here. So in this case, one of the things that we know now is we know that in this instance, x equals -1. We now have a new equation. So one of the things that you need to remember is that this equation is as an x to the 4th. The arrow here is going to bring it down, so that this is now an x to the 3rd equation. Okay, so we have removed one of our powers. Our smartest thing to do, once you need to has a multiplicity. So in the -1, this new equation, one going to draw our synthetic. So the first one comes down the box. Now we're going to, so 3 number times the box, -4 is 4. We received a 0, mean 1 a factor, -1. Now shown, and again, this was the arrow of an x squared equal. We can hear what we end up x. We can solve. What we would do is divide squared plus 4 equals, so if we go, and in this factor following, it's minus squared plus 1. Now how does it because if we were to reverse, remember you move them to set it equal to 0. We would end the way that we all out x times would work. If you are online, is going to individual with the multi. I always whatever your most comfortable one you want to. Now in this case, we also want to x equal. All right, let's look at one more. That we have again we're going to go with this. Okay. 9. Where's solution? And go here. Biggest hints that I have about the number of ways this equation into your calculator 0 as a check. Otherwise, in 20, so look at these here. They have. I would do. Okay, how about that? 1, 3, a 4. times the give us the negative 2 times the you get 18 times the 4. When we vertically add, we get 0. So again, right here, this tells us, because we came to a 0, that the 3 works. And so one of the things we know here is that this tells us we have x minus 3 as a factor. Again, like before, this started as an x to the 4th. The arrow says that we're going to subtract a power down, so this becomes an x to the 3rd. So let's go ahead and do it again. Now, you can rewrite it out separate, or another trick that I've seen done before is going ahead, just simply drawing a new box, arrowing down what we're going to do, and drawing your solution line. And we're going to build upon what we already did. Okay? Now, remember the good old rule. Once you find a factor that works, I suggest testing it again to see if it still works. This is your way of checking for a multiplicity. So in this case, we're going to drop the 1. Again, run through it. Bottom times the box goes underneath, so this is a 3. When we vertically add, you get negative 1. Bottom times your box goes in the next place, so this is a negative 3. When we add them, we get negative 6. Bottom times the box goes in the next. When we vertically in, have found again, this telling us 1 here. Now, if we're looking, this goes from a cube down to an x squared. So there's a few things that we can do. At this point, it's an x squared equation. So I would highly recommend you simply solve. This is x squared minus x minus 6 equals 0. And in this case, we can factor this to end up getting x minus 3 and x plus 2. So now, I had a power of 4, which means I needed 4 factors. I have them, 1, 2, 3, 4. So in this case, I have everything I need. So my factors here are x minus 3, x minus 3, x minus 3, x plus 2. Now again, the other way that we could have written this was to say x minus 3, and this is cubed, with an x plus 2. Okay, that's another way you could write it. Now in this case, when we want to solve it, that means set your factors equal to 0. So here we would end up with x equaling 3 and x equaling negative 2. Now a hint for your solving piece, the number in the box is essentially the number if you solved it. So notice here my number in the box, or my factor, is a 3. And if I look at what it was when I solved, it's a 3. Okay? So that is another hint that you can use when trying to remember what all information needs to be included. So there you have it, a couple examples on being able to factor larger polynomials using synthetic division as your process. So if you have any questions, please let me know. If you have any additional examples that you would like to be seen, let me know that too. I'd be more than happy to work them out. Otherwise, I do hope you enjoyed yourself. Talk with you next time.